much around being data first and using declarative HTML and data binding. I'm going to talk about Angular 2, but before we do that, I know that there are still people that build on Angular 1 or have existing legacy Angular 1 apps. And you might be wondering, well, a lot of this progressive web app stuff, great. Does it work with Angular 1? Yes, but with caveats. So I tried building an Angular 1.5 app just to demonstrate this, and I was trying to think of what app I would build. I initially thought of building like an app that would show me the nearest places I could go and skydive. Then I realized that I don't skydive. The closest thing to me skydiving is probably zooming in on a Google map really, really fast. And that's basically the same thing, so I'm fine with that. So this is the app that I built. It's called Cherry. Built this in about an hour or two. This is using Angular 1. As you can see, we've got add to home screen features, splash screen, offline support with service worker. Unfortunately, the downside to this app is that it just doesn't meet our performance budgets. You take a look at, on 3G, you take a look at where your goals are for fast first paint. It's taking 2,500 milliseconds for first paint in this app. Our speed index metrics are 8,000, 8,400. That's crazy. We shouldn't be taking so long for our users to actually be able to start using this application. Luckily, with Service Worker in place, we are able to slash these numbers in half. So if you're in a place where you can't, in the near term, move over to rewriting your application to use a modern framework, I would consider using Service Worker. You're still going to get some wins there, but it's not going to be quite as good as something that has support for server-side rendering and is developed with mobile in mind. That takes us to Angular 2. So Angular 2 is component-based, uses directives, and has an improved dependency injection model. And the Angular mobile team have recently been focusing a lot of their time trying to make it easier to build progressive web apps using their tooling. So we're going to talk a little bit about that. Now, to get started with Angular 2 apps, a lot of the time, they'll recommend using the Angular CLI. This does everything from setting up your TypeScript and typings for you, bootstrapping your app, using System.js to load up your app. And so we're just going to use that to very quickly scaffold up a new app. Now, one thing to keep in mind is a new flag called mobile. Now, what mobile will give you is all of this. When you create a new app, it's going to give you a few extra things that help you make a progressive web app. Things like going and scaffolding you out a web application manifest, a build step to generate your application shell for your application's root component, and service worker support for application caching. So things like add to home screen are possible. You'll still get the splash screen. You'll still get your add to home screen icons. All of those are fleshed out for you. And the manifest doesn't look too different to the manifest you've looked at today. It's exactly what you'd expect it to be. Now, most of the time when we're developing apps, we use a site called realfavicon-generator.net to generate our icons for us. It just avoids you having to handcraft these yourself. Next up, we've got the application shell. So by creating a new project with the Angular CLI and the mobile flag, the application already has a build step configured to go and generate you an application shell from your root component. So here, we're going to just use the main component that Angular CLI created for us to create our application shell. We're going to do something with Angular material. So let's say that we will just add a toolbar to this application. So we npm install the dependencies we need for this toolbar. And then we register the toolbar inside of our main Hello Mobile component in this case. So we see that we've got application shell directives that are going to help us with setting up the application shell. We've got our toolbar in place. This isn't particularly useful just yet. So we're going to go and we're going to add in a proper toolbar in there inside of our template. So it says Hello Mobile. So far, this is fine. This isn't particularly exciting. What is exciting is these two little helpers. So these two helpers are shell render and shell no render. And these are kind of badass. So shell render will allow you to define any UI that you want to display on the screen before your main Angular bundle has completed asynchronously loading in. Shell no render is what's going to be displayed after the entire application has fully rendered out, meaning that you can define your application shell declaratively right inside of your component. So in this case, we can do things like just make sure that the toolbar and at least a loading spinner, so that thing that we wanted to achieve for first meaningful paint is in place, and then we can use shell no render for anything else that comes after the fact. Now, the Angular Mobile Toolkit comes with support for generating a service worker that will automatically cache your assets for you. It doesn't yet entirely support things like dynamic caching, but it does support caching for your static assets. And you can go and you can start using these on serve, using the prod flag, on build, again, using the prod flag. I've been hacking on a little Dribble API client called Berry using this stuff, and I found it particularly good for that. Offline support wasn't very difficult to get in place. And using the CLI, it's actually going to scaffold you out one of these files in the background. So this is an Angular service worker manifest. It contains basically all of the files that are going to be cached, as well as a hash that allows service worker to know whether or not they're stale or not. So what do the numbers look like? We're going to take a look at an Angular weather app that the team have been working on. And this uses the application shell model, it uses Angular CLI, it uses a lot of the tooling that they've recently been working on. And with Lighthouse, these are the metrics that we currently get. So first paint is about 1,083 milliseconds. That could be better. Speed index is 2,271, and the speed index on repeat visit is 599. Now these aren't terrible numbers. These are actually pretty good numbers, but we can do better. So recently, the Angular mobile team have also been looking at offline compilation. Now, in Angular 1, template compilation can happen many times during your application's lifecycle. And Angular 2 tries to move some of this work into a build step, making it a lot more efficient. So offline compilation happens during a build step, as I said, and it no longer happens during the browser. So we convert things like templates into code on the server so we don't have to ship the compiler at all. And what this leads to in terms of application performance is some stark differences. Fast first paint is happening at 479 milliseconds. Speed index is almost exactly where we want it to be. It's very, very close to 1,000. And repeat visit is close to nothing. You're getting what's basically an instant application on repeat visit. This is kind of awesome. Now, we also wanted to take a look at what server-side rendering would look like for these applications, because we can still squeeze out a little bit more performance here. So getting your users a first view really, really fast is kind of critical these days. And Angular Universal basically helps you achieve this with pre-rendering on the server. So the way this works is whenever a user goes and they click on a link to your web app, Angular Universal is going to server-side render the initial response, get it to you. So the user has at least some UI in front of them they can take a look at. A couple of seconds later, it'll then asynchronously load in the rest of the bundle. It'll bootstrap, the client will take over. This is sometimes called hydration. And it just means that you lead yourself to having a pretty good perceived load time performance overall. Some of the interesting things that I came across in this experience over the last couple of weeks was that this notion of user events being stuck in uncanny valley is pretty much consistent across like React, Angular, and Ember. Even with server-side rendering, your first view, you're going to still end up in places where your user can still end up clicking, touching pieces of UI where they're trying to have things happen, and they'll just be stuck until your entire content bundle has ended up there. So in the Angular community, gap events is the term that they use here. So things that the user is going to try accomplishing while they're still waiting for bootstrapping to occur. But thankfully, the Angular team have been working on an interesting solution called pre-boot that basically allows you to respond to and play back events. So I'm not saying this is the perfect solution to this problem. It's kind of very interesting, though. If the user does try interacting with your app, as soon as it has finished bootstrapping, it will replay all of those events for you so that they still, they're not having to redo work. It's kind of interesting. So to get this set up, again, we use Express. We just import in Angular Universal, which doesn't take a lot of work. And this is what the numbers look like. We start off with a speed index of 2,640 on 3G. Once we've added in offline compilation, service worker, universal rendering, we're down to almost nothing. You're in a place where universal rendering has made a huge difference. And this is very much true of the React app we were working on earlier as well. Server-side rendering makes a huge difference, really huge difference. And as you can see, with service worker in place again, repeat visit is close to nothing. Users are going to feel it being instant. Now, the Angular mobile team are working on making all of the developer conveniences around this stuff a lot more low friction. Some of this work is still very much early on. They're working on improving their service worker support, adding pass-through caching support, a data savings mode, making sure that they're looking at HTTP2 and how that interacts with service worker, and just improving the docs. So if you're working on an Angular 2 app at the moment, go check out Mobile Toolkit. And finally, we have Ember.js. Now, Ember is a framework for building ambitious web applications. It utilizes components. Routing in Ember is a core tenet there. And the Ember router, similar to the React router, works just fine on both the client and the server. Now, interestingly, frameworks have a bad rap when it comes to performance, right? Henrik Jortig recently said that in his opinion, the data for Angular and I think he was talking about Angular 1 and Ember flat out disqualified them for mobile use. And this is mainly down to bundle size. Like Ember as a framework still has a relatively large bundle size. Now the Ember team acknowledged this a couple of months ago, and they've been looking at how they could improve the situation with mobile in mind. So they've taken a look at both first boot and repeat boot for this problem. Now, on first boot, they're looking at fast boot, so their solution for server-side rendering. And I really love fast boot. We'll talk about it in a minute. And on repeat boot, they're looking at service worker. They're also looking at some other interesting ideas, things like string loading, which basically means shipping JavaScript modules as strings so that you only pay the valuation cost for the modules that you're using, and Project Svelte for stripping back features that you're not using in Ember. I was trying to think about what progressive app I'd build for this, and I came across the idea of building a puzzle app that would just say go outside when you're complete. It's maybe not the best idea. But I ended up on SuperCoolBlog, which is basically a blog app. This is the final thing that we end up building for Ember. Basically, this is an offline-first Ember application that works instantly, meets our performance targets, uses server-side rendering, works without JavaScript enabled, by the way. So let's take a look at how something like this can be constructed. Now, applications in Ember are crafted using the Ember CLI. And you go and you just install it, let you scaffold out your application architecture, a very basic file structure, go and serve it. You get a very, very basic app out of the end of that. Now, routes and making sure that your routes are right and you have a good routing setup will make things like server-side rendering so much easier. So we make sure that in this application we've got our routes figured out. We've basically got very simple routes. We've got one for different categories we've got going on. We want to display articles for. And all of the content for this application actually just exists in JSON files. I could be using a backend, an API of some sort. I could just be caching stuff coming back from Firebase. But in this case, I just have all of my data locally. And it just makes caching a little bit easier. So this is what our very, very basic application looks like at the very start. So we've used Ember CLI, we've scaffolded out our views, added some CSS. We're just using templates to load in the content. It's nothing particularly complex just yet. Now, the first thing we're going to do is add in the web app manifest. Similar to the other sites, it's not particularly difficult. It's like something that takes 5 minutes a lot of the time. So we add this in, and this just makes sure that when the user comes to trying to add the site to their home screen or launch it, they're able to get home screen icons, splash screen icons in place. Next up, we have service worker support. Now, about a year ago, the Ember team said that they'd been watching some of Jake Archibald's service worker videos, and they were really excited about them. One of the things they wanted to do, and this is true, I think, of a lot of frameworks, is they want to take web platform features and try to make them usable for their users with as little friction as possible and automate that process as much as they can. So Ember wanted to make this something that's free. They're not quite yet there with their baked-in support for service worker. But luckily, the community put together an add-on for Ember CLI called Broccoli Service Worker. Now, one of the cool things about Broccoli Service Worker is it happens to build on top of Service Worker Toolbox. So that thing that we've been using for our React app earlier on. Now, the configuration for this looks a little bit like this. Basically, we're inside our Ember environment. I'm just saying that I'd like to make sure that debug messages are enabled and the service worker is enabled. But I can actually get control over a lot more of my offline experience, being able to set things like network first URLs, paths to include and exclude. And when it comes to Service Worker Toolbox, you actually get quite a lot of control over different network strategies. You're able to say, well, I'd like you to go out to the network first and then fall back to the cache, or use the cache first and then fall back to the network, or try to race both strategies and make sure that whichever wins actually delivers you the content. You've got a lot of flexibility there. So once we have offline support in place, I'm able to launch my application in airplane mode and just view any of the content I've previously seen. I can go and read articles, I can go and look at menu items, and all